Let's talk about two very different gaming devices from completely different eras, the PlayStation 3 and the Lenovo Legion Go with its Ryzen Z1 Extreme. First, the PS3, released back in 2006. At its heart was the Cell Broadband Engine CPU. This was a revolutionary chip for its time. It ran at 3.2 GHz and featured one power processing element, basically a Power PC core, supported by 7 synergistic processing elements, or SPEs. These were specialized vector processors great at parallel tasks. Ran at 3.2 GHz, same as the main PPE, had its own 256 kilobytes of local memory, local store, excelled at single instruction, multiple data, perfect for things like physics calculations, 3D graphics, audio processing, encryption, and scientific simulations. Featured a large 128-bit register file and dual-issue execution pipelines. Think of the PPE, power processing element, as the manager or general purpose brain, while the 8 SPEs were the tireless workers, optimized for heavy number crunching. Sony, IBM, and Toshiba designed the Cell chip with 8 SPEs on the die for a very practical manufacturing reason. Chip manufacturing is imperfect. Some SPEs on a wafer might have defects. By building the chip with 8 SPEs, if one had a defect, it could be disabled using laser trimming, and the chip could still be sold as a fully functional 7 SPE version. Even on perfect chips, Sony disabled one SPE in every PS3 for consistency and to reserve it for the operating system. So in the PlayStation 3, one PPE dual-threaded, 7 active SPEs, 6 available for games, plus one reserved for the OS. This approach dramatically increased the number of usable chips coming off the production line, lowering costs. Why was this design so revolutionary? The Cell's architecture was incredibly forward-thinking for 2005-2006. It delivered massive parallel processing power in a single chip, something that was very rare and expensive at the time. While a traditional CPU focused on high clock speeds and complex, out-of-order execution, the Cell took a different route. Many simpler, highly efficient cores working together. This design was exceptionally good at streaming data and running highly parallel workloads. In 2010, the U.S. Air Force Research Laboratory, AFRL, made headlines by building one of the most unusual supercomputers ever created, the Condor Cluster. It was constructed using 1,760 PlayStation 3 consoles, approximately 500 trillion floating point operations per second. At the time of its unveiling, it ranked as the 33rd fastest supercomputer in the world. The Air Force chose the PS3 because the Cell processor was exceptionally good at certain types of parallel workloads. The Condor Cluster was mainly used for processing large amounts of high-definition satellite and surveillance imagery, research into pattern recognition and intelligence analysis. The project showed how forward-thinking the Cell design was. While it was difficult to program for, which hurt its adoption in games, its strengths in parallel data processing made it very attractive for specialized scientific and military workloads. Paired with that was the RSX Reality Synthesizer GPU, developed by NVIDIA. It was clocked at around 550 MHz and based on the GeForce 7800 GTX architecture. It had 256 megabytes of dedicated GDDR3 video memory. The console also had 256 megabytes of high-speed XDR main RAM. When the PS3 launched, this hardware was cutting edge. It delivered impressive 1080p gaming with advanced effects for the time, like high dynamic range lighting and complex physics. The Cell processor, in particular, was hyped as a supercomputer on a chip. In raw floating point performance, the system offered around 200 to 400 gigaflops combined. It was powerful enough to run ambitious exclusives like Uncharted, The Last of Us, and God of War 3 beautifully. For 2006, the PS3 was a beast. Now, fast forward to today with the Lenovo Legion Go and its AMD Ryzen Z1 Extreme processor. This is a compact APU that packs 8 Zen 4 CPU cores with 16 threads. It has a base clock of 3.3 GHz, but can boost all the way up to 5.1 GHz. On the graphics side, it features the Radeon 780M iGPU with 12 compute units based on the modern RDNA3 architecture. This GPU can run at speeds up to 2.7 GHz and delivers up to 8.6 teraflops of performance. The whole thing is backed by a generous 16 gigabytes of fast LPDDR5X RAM. So how do they compare? The difference is night and day. The Legion Go's CPU is vastly more powerful in both single-threaded and multi-threaded performance, thanks to modern architecture and much higher clocks. But the real jaw-dropper is the GPU. The 780M offers roughly 40 times the floating point performance of the PS3's RSX. In real gaming scenarios, we're looking at 15 to 30 times the overall graphics power. Beyond raw power, the efficiency is incredible. The entire Legion Go runs at just 15 to 30 watts in handheld mode, while the PS3 was pulling 150 to 200 watts or more under load. That means the Legion Go delivers exponentially more performance, using a fraction of the power and in a tiny, portable form factor. In short, the Legion Go doesn't just beat the PS3, it completely dominates it. It can emulate PS3 games at higher resolutions and frame rates while still having plenty of headroom for much more demanding modern titles. The technology leap between 2006 and now is absolutely massive.